Hello class, I hope everyone's doing well when they start watching this video. Today we're going to be talking about the scientific method, which I know is a little bit of a review, but we're going to be talking about or doing some more science related activities. We're not going to quite do a science fair this year, just because of everything that's going on. It would be not feasible. We wouldn't be able to complete it like we've done it in the years before, but we're going to be doing a science day next Friday. So just to get us in there kind of thinking about the scientific method, I just wanted to review it today with some fun examples of experiments related to thermal energy. So trying to tie it back into what we're learning. So some questions always to get us thinking before we get started is, what do we already know about the scientific method? So just start to think about years past. What have you learned? Maybe are there anything that comes to mind? Do you guys remember any of the important steps that there is and during our scientific method, or even what are some other experiments you have done for science fair in the past? Maybe is another good way to think about it. So our whole goal for today is review some steps of the scientific method, and then brainstorm and then watch an experiment together. So that's what we're going to do. We're going to walk through what the scientific method might look like for our examples. So our first thing that we're going to do is review our steps in the scientific method. So step one is an observation, and we can see over here on the right we have a nice picture that says observation, and then it has an arrow going to question. So step two is going to be ask a question. Then we're going to go to hypothesis, which is step three, test a hypothesis. Step 4, we're going to plan or design an experiment. Step 5, we're going to have analysis of our results. And then step 6 is conclusion. And I like this picture because it goes back into observation. A lot of the time, when we're all the way done with our conclusion, we say, maybe I have a new observation that I noticed, or maybe I have a new question that I want to test. So it's a cycle that happens over and over. We can always keep doing it more and more. So a lot of the time I like to think of like making an observation as just anything I see in the world that I'm curious about. Anything at all, I can start to ask, why does that happen? Or is it always going to be, this way that I see right now? Or can I change something about the situation to see how the outcome will change? So that's the idea, the thought process of the scientific method. So our first step is observation. So I've kind of helped us. I have an experiment already in mind. Usually you would do this without an experiment in mind, just all on your own. So what things do you notice about heat transfer is our question, just to kind of get us thinking for our observations. So some things that I have noticed about heat transfer are, it takes a long time to heat up water. Curious, why does it take so long? Is there a reason behind that? Also, why do some objects heat up faster than others? It seems that, again, water takes up a long time to heat up, but maybe oil or even like a metal doesn't take very long. So why does that happen? Or some of these observations that I'm making, some possible questions now are related to some objects heat up faster than others. That's going to be the observation we're going to be trying to test today. Is some questions that I have, at least. I'm curious. I'd encourage you guys to pause the video or think of your own. But some of the ones that I came up with were, why do different objects heat up faster than others? Or which would heat up the fastest, metal, plastic, or wood? So I like the first one because it's asking the question why. But our second question is a lot better because it's more specific. When we're doing science, we want to be very specific. We want to have our questions very direct, very testable questions. And then we also want to be able to measure things. So our second question is a little bit better because now by asking which one would heat up the fastest, metal, plastic, or wood, we can go and design an experiment around that. But before we get to our experiment, we want to form a hypothesis. And a hypothesis is an educated guess. And I say educated because we often will do some research to figure this out. So I might start Googling, well, which one does heat up fastest? Wood, plastic, or metal, and why? And so maybe on Google I could find some answers for this, but it's always good to do some research and then still do your own experiment to see if you get the same results as someone else. We don't always just want to assume what we're told is always right. Sometimes we want to question and test for ourselves to make sure we get the same results. So it's always good to do some research, and it's also important to only test one variable. So if we are testing too many variables, then our results could be coming from a combination of these two variables, and it gets really complicated. Whereas if we know we only test one variable that's changing, when we keep everything else the same in between our tests, that one variable is going to be the determining one, and we know that it's only affected by that. So the hypothesis I came up with is by placing a metal, plastic, and wooden spoon in a cup filled with hot water, the metal spoon will gain the most heat. So really our hypothesis is the metal spoon will gain the most heat out of these three ones we're going to try. A quick note on just different kinds of variables. We have three different kinds. We have a dependent, independent, and a control. So our dependent one is a variable that you can measure. So in our picture up here we have the amount of fish. So we have a fisherman going. He's changing the time of day, but he's using the same kind of bait every time and the same kind of fishing pole. But he's curious how many fish he will get depending on the time of day. So our independent variable, the variable that we control, is the time of day we're fishing. So we're gonna try in the morning, we're gonna try at midday, and then at night, and see with this specific kind of bait in this same pond, how are we gonna get the most fish? That being said, our other variables are our control variables, which is a variable that you keep the same. So, for example, we always want to keep the same bait and the same pole, because if we're changing the time of day, our independent variable, and the type of bait, we won't know really if we're getting more fish because it's nighttime or because we changed our bait. So we want to keep all our other variables the same or constant while we are testing our independent variable. So our experiment, we're going to take 3 spoons, a metal, plastic, and wooden spoon, and place them in a cup with hot water. So I want you guys to think, how can we measure which one heats up the most? So our experiment is to see which one gets hottest. How can we measure that? Because it's all about measuring things. The first thing I thought of was just a temperature gun, especially with COVID. I've seen a lot more of these temperature guns as you walk into the store. Someone takes your temperature maybe. So that's a very common thing. That's what I thought of first. Another way we could do it that's a little bit more visual is we could place a little bit of butter on each spoon, and then the first one for the butter to melt and slide down has gained the heat the fastest. So that's the one that we're going to test and use today. I don't love this way to do it, but it's the way the video I found does it, so we're going to do it that way. So just to practice defining our variables, what is our dependent variable in this? The one that like our fish is the amount of fish we're catching. So our dependent variable is going to be the temperature of the spoon. So this is what we're testing. Which one is going to get the hottest, the fastest, the conduction, the ability for the spoon to transfer heat. Our independent variable is going to be the type of material. So this is what we've decided to change. And then our control variable is everything we want to keep the same. So we want to keep the amount of water the same, the temperature of the water, the size of the spoon, lots and lots of video, maybe the temperature of the room. We want to keep all of these the same. So that the only thing we're changing, the only thing that's different between each of them is the material. So this is our video, so please pause our video and go watch that. And then we'll finish our analysis. So after seeing that, of course, what did you notice? We noticed that the butter and bead on the metal spoon moved first. So it's melted the butter on the metal spoon first, so that got hotter quicker than anything else. And how long did it take? I was watching the video. In the video, it took about 30 seconds. I don't know if that is real time. I didn't see a timer next to it or anything, so we would want to double check ourselves. But in the video, it took about 30 seconds for that middle spoon, the butter on the middle spoon, to start to slide. So, also, this wasn't shown, but I would have liked to seen how long it took for the plastic or the wooden spoon to heat up, and which one would start sliding next. So we learned that the metal spoon conducted the most heat, got hotter faster than any other one, but what was second and what was third is something I'm curious about too. So, was our hypothesis correct? Why? Yes, the metal spoon heated up first because it has a lower heat capacity, and that is also like saying it is a better conductor of heat. So, water, we've learned, has a high heat capacity and takes forever to warm up. Anything with a low heat capacity warms up very quickly. So this metal has a low heat capacity. How could we improve the experiment? I thought about maybe changing our water temperature and still to make sure that our metal spoon always would gain the most energy or get hotter the fastest. We could also test different types of materials besides just plastic, metal, or wood. I think measuring the temperatures would be better so that we can get exact results. We can say the wooden spoon rose 10 degrees more than anything else. So I thought that would be a fun way to improve the experiment. And then what are some other questions you have relating to the thermal energy? Just relating to this own experiment, like I said, I would like to see what was second and third in terms of the order of how fast something heated up. And there's lots of other ones we can think of too. So there's one more experiment I was going to have us work through real fast. So the observation I found is a different one related to thermal energy, is that a balloon filled with air explodes when it's placed over a flame. So my question is, can anything be placed inside the balloon to allow it to absorb the heat and not explode? So my hypothesis is by placing water in the balloon, placing water in the balloon will allow it to not explode when held over a flame. And we have this really cool video doing just that, putting water in a balloon and seeing what happens when it's placed over a flame. So please go watch that. And then we'll do our analysis. So when a balloon was filled with water, it did not explode, but it did burn the balloon. I did not predict it would burn. I just thought it wouldn't explode. So that we learned something new. And then our conclusion is we have to respond to our hypothesis. So our hypothesis was correct because the balloon filled with water absorbed the heat rather than exploding like the balloon filled with air did. To improve this experiment, I think we could try different types of liquid. So what if we put Coca-Cola in our balloon? What if we put acetone? What if we put salt water in? How would that change our results, or even different types of balloon? So maybe put a blue balloon absorb or pop better or explode more than a red balloon, or maybe a small balloon versus a big balloon. So these are some of the questions we could test more and more as we go forward. So those are just some ideas to get us thinking about the scientific method and some fun experiments I thought to illustrate how we can use our scientific method. But I hope you guys enjoyed our presentation. As always, if you have questions, please let me know.